Oh, sorry. I hate when old folks do that. Start repeating stories. All right. Go ahead and clear. Doesn't my calculator look cool though? Look at my calculator. All right, so let's go ahead and clear. Go ahead and clear the memory. So second plus 712. Clear that memory. And I'm going to go into the graphing screen. It's dark right here because that's where the light is reflecting off my calculator screen. That's why it's dark. All right, and so we are going to graph this on the calculator. So what we do is I'm going to go ahead and type x plus 2, just like normal. And then for me to be able to tell the calculator to do a limited domain, I put a divide symbol because I'm stopping the equation, and I put a parenthesis. So what we're doing, your calculator started reading this as, okay, I have an equation x plus 2, and what I'm doing now is it's almost like I'm computer programming. I'm going to tell the calculator to only do that for a certain portion of the graph, and we're going to do it for x is less than 1. And so what you do now is you type x, and to get the less than symbol, you do second math. Second math is less than 1. All right. And if you hit graph, it will graph that line, but it will stop at 1. See that? Okay. Yeah. Then it will look about the same. Yeah. Will you bring it up to me? It's possible. It might be. I didn't think that was a thing that was different, but it's possible. I just cleared the memory and did it again, and it worked. All right, so now we go back to y equals, and we go to the second equation. And this time we're going to type x minus 1 squared. And then we're going to do our slash and our parenthesis. And we're going to do x is greater than or equal to 1. X, and then second math is greater than or equal to 1. And it looks like what we graphed, so that's good. Now, if I try to evaluate my calculator at an x value of 1, what y value should it tell me? The bottom one, it should tell me 0, right? Okay, so if I do second trace, yes? Will you bring it up? If I do second trace and I plug 1 in for x, you can see that the cursor, you didn't get your squared in there, or your parentheses. Here, let me if you plug in, did I do it equal to 1? Oh, it should have worked. Well, you can see it on the table anyway. If you look at the x value of 1, you can see the first one doesn't work, but the second one gives you a coordinate of 0. Does that make sense? So you can see it. Okay, go ahead and hit y equals again. We're going to clear these. We're going to do the next one. Okay, so for this one, we have -3. And then we're going to do our slash. And these ones are a little bit harder to type in because your calculator will not do the sandwich like that. When you type it in your calculator, you have to start with x. So we're going to write two things. We're going to say x is greater than -5 and x is less than or equal to -1. That's how you type it in when you have to do something like this, okay? So I've got my slash. I'm going to say x, and then the first thing I'm going to type is greater than -5. So second math is greater than -5. And then I'm going to get the word and in there. And the way that I get the word and in there is I hit second math, I go over to logic, and then I have and. So x is greater than -5 and hold on, get your X in there. X, huh? The and. You do second math, right arrow. There you go. And X is second math less than or equal to -1. So greater than -5, less than or equal to -1, and then if I hit graph, I can see just that little piece of a horizontal line. And then we're going to go back up and we're going to go to y2, -x squared plus 4 slash, and we're going to get x is greater than -1. X is greater than -1. So if you're not sure if you graph something right, that's a good way to be able to go back and check. Okay, and then if you want to know if these should be filled in or not, we can look at the table. Should it be filled in at -5? It says error, so it should not be filled in. Does that make sense? That's not a real point on the graph, so it should not be filled in. Should it be filled in at -1? Yes, there's a point there. Then over here for the other one, should the other one be filled in at -1? No, because there's an error there. So that's telling us that it shouldn't be filled in. Okay. All right, any questions on how we graph those? Go back to what part? What part? Like none of it? Okay, I can help you in a little bit. Okay. Any other questions on it? Okay, so I'm going to go ahead and give you an assignment, and we're going to graph some of these together. So on this page, we've got 2 linear functions. That should be pretty okay. What are these two when they're written like that? It's just a number. Yeah, what are they? Yeah, it's a horizontal line, right? Those are just horizontal lines. Is there anything on the first page that you're a little bit nervous about, like, ooh, maybe we should do that one together because that one might be difficult? Which one should we do together just to practice? 3? Okay. So if we do number 3 together, the first thing we have is a straight line, y equals 2x plus 4, right? We have y equals mx plus b, so we have a y-intercept of 4 and a slope of +2. So how do I graph that? I start at 4, and then how do I do the slope? Up 2 over 1, up 2 over 1. I'm going to go in each direction, and I'm doing this lightly and in pencil. Why am I doing it lightly and in pencil? I'm going to have to erase part of it. Okay, so there's my line, lightly and in pencil. And it says that I'm keeping the part that is less than or equal to -2. So what do I do? I find where the x value is -2. I put a circle there. Do I fill in the circle or not? I fill it in because this is equal to. And then I'm keeping all the numbers less than that, so which direction do I go? Left, and the arrow points left. So I go to the left. I make it dark. And then what do I do with the rest? I erase it. Okay. All right, the other one is an absolute value graph. So I've got the points -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. And then what transformation is happening to that absolute value graph? It's being shifted up 2. All right, so I've got -2, 4, -1, 3, 0, 2, 1, 3, 2, 4. Okay, and I can go ahead and just, I know what the V does. So I can go ahead and just kind of lightly draw that. All right, and then what do I do? By -2, I put a circle on it. Do I fill it in? No, I do not fill it in because it does not say equal. And then what do? I make everything greater than -2, which is to the right. I make that all dark. Okay, and then what do? And then I erase the rest, and then I'm done. What color do you guys think my pencil is? Yellow and pink, or green and blue. Crazy, right? Why would I not? It's a recording. You can show that to your mom. All right. Let's look. That's the light reflecting. That's why it's dark. So ready? Ready? It'll disappear. Ta-da. I'm covering up it's the light reflecting from the document camera onto the desk, and because it's bright, it's reflecting dark because the colors are backwards. Yeah. All right. Let's do one on the second page. What do you guys see on the second page where you're like, whoa, what happened? Why? Yeah, let's do number 10. Okay, let's do this one using our calculator to give us the points. So I'm not going to graph it as a piecewise. I'm just going to use it to give me the points for the absolute value of x plus 1. Do you guys remember how to type in absolute value of x? Yeah. Jamie, I think I did not leave you a page. We had the math button, and then go over to number. That's the first one. All right, so I'm going to go ahead and graph that. And then I'm going to do second graph so I can look at my table. All right, so the vertex is at 0, 1. -2, 3. -3, 4. +1, 2. So there's my absolute value graph. Yeah. And I got those points from my calculator. So what do I do now? Yeah.
So you would put an open circle on -2.
For number 10?
Yeah. Or closed circle.
Closed circle on -3. Okay. And then which part are we keeping? The left. The arrow points to the left. So it's saying all the numbers less than -3, which is to the left of -3. So we make that part dark. And then we erase the rest. Does it even look like an absolute value graph anymore? No, it's like that could be a linear function. What could they have put instead? Y equals what? Yeah. They could have put -x plus 1. Does that kind of fit what you guys remember a little bit from writing the absolute value functions as graphs? This is like the negative version because it's on the left side. All right. And then what do we do for the other part? Let's go ahead and graph that. So we've got square root of x plus 2. So I can't graph anything at -3 because it gives me an error. But for -2, I have 0. For -1, I have 1. For 2, I have 2. So I'm not trying to graph the decimals. I'm just trying to graph the whole numbers that I see. And then for 7, I have 3. Okay. And what does it say for this graph? What do we do for this one? Yeah, if x is greater than -3, and what do we see? What's kind of weird about it? Yeah. Yeah, you can't plot -3 on that graph because if you tried to plug -3 in for x, what would happen? Yeah, you'd get an error message. You'd get the square root of -1, which is imaginary. So for this one, we can actually use the entire curve because the entire curve is to the right of -3, so we get to keep the whole thing. Fancy. That's it, we're done. So, yep. A little bit further than we would have had to have a circle, but this one didn't go far enough for us to need a circle. Okay, so go ahead and get started. The answer key is on the wall. If you need to check anything, I'll get some music on.